Yeah, good evening everyone. So John again, let's start off. So the last thing we did was this thing, the particles chasing each other. Others need to keep your cams on. Let's start off with the problem. Let's say we have a cat here. Cat is moving horizontally with a constant speed u. At a particular distance here, we got a dog that is chasing the cat with speed v. Initial distance between them is L. So a cat is moving horizontally with speed u. This is a good question. The dog is chasing the cat with speed v, where v is greater than u. So the dog speed is greater than the cat speed, such that its velocity vector is always towards the cat. First question, find the time when the dog catches the cat. The second question, I'll give you that as homework. If the cat ka speed and the dog ka speed is equal, find minimum distance between the cat and the dog. Let me explain you the question a little more. You know, how is this dog chasing here? When the cat has gone here, the dog must have come somewhat like this. The dog is looking at the cat like this, and the cat is going with you. After some time, when the cat has come here, the dog is going like this. Are you getting how it is chasing? The dog is always chasing the cat like this. So it is always looking at this thing. This is how the dog is chasing the cat. As the cat is running horizontally, the dog is seeing the cat and running behind it. The speed of the cat is u, the speed of the dog is v, and the initial distance between them is L. So the question is, find the time when the dog catches the cat. This is a good one. It's a standard one, but it is slightly complex. You should know how to do this beforehand. But give it a try for a minute and then I'll show you how to do. This thing, there's only one way to do this problem, and it is kind of like you need to remember how to do this. I hope the question is clear. Anyone didn't get the question, please ask. The cat is simply running with a constant speed in a straight line. The dog is chasing the cat and running behind it. How do we approach this? Angles are there, but let's see. No, Pratyush, that's not the answer. How did you even get that answer? V square plus u square. Listen, this is a little different actually. You should know the process of how to handle this. There's only one way to do this problem. So you guys can try that homework problem as a thing. That will be a good one to try. I'll show you the first part when they meet. Look at this scenario here. So if you look at the path at any time, the dog is here, velocity is v, the cat is here, and this is going with you. If you look at the angle, this angle is theta, and observe this theta is changing here. As you're going towards the cat, the theta is also changing. So finally, when both the cat and the dog meet, it's like this. This is the meet here. Now, the horizontal distance traveled by the cat is anyway traveling horizontally only, is equal to horizontal distance traveled by the dog. So cat has traveled a distance of u into t. What about the dog? The dog ka horizontal velocity is how much? V cos theta. But understand theta is not constant. Therefore, it should be integral v cos theta dt. Now here the problem is I don't know theta, I don't know dt. I can't integrate this directly. This is your equation 1. Have a look at this statement. The horizontal distance traveled with the cat is u into t because the cat is going with a constant speed. The horizontal velocity of the dog is v cos theta into dt. You have to integrate because the velocity is not constant. This is your equation 1. All clear? Any doubts on this part? Clear with this, Vivan? Siddharth? Anshul? Clear with this? Pratyush? Arya? Ekansh? Ali? Saurja? Clear? Darshini? Clear? Who else is missing today? Dikshita is missing. Now, the second part. So somehow we need to get that cos theta, and we need to eliminate that. Just a minute. Let me take the attendance. This is what we do the second part. Let's solve with respect to the cat. So if you ask the cat, what is the dog doing? This is what the cat will see. The cat is going with speed u. The dog ka velocity is v. This is also angle theta. This component will be u cos theta. This component will be u sin theta. So if you stop with respect to the cat will think, okay, I came to rest. Now the dog ka velocity will become this way. This is v, u cos theta backward, and u sin theta this way. So this is the cat ka perspective. Huh? So cat will see the dog is coming towards the cat with a speed of v minus u cos theta, and the perpendicular component is u sin theta. So the path of this thing will look like this. This is the path of the cat, the dog, as seen by the cat. And among these two velocities, this velocity is responsible for the dog to catch the cat. Because that is the velocity which is bringing it closer and closer. So from there we get integral v minus u cos theta, the relative velocity between them, dt should be equal to the displacement. Displacement is nothing but final minus initial position. Final position is 0 because they're meeting each other. Initial is L. This would be your second equation. V minus u cos theta into dt is equal to L. This is your V relative. Please have a look at this page. So if you stop the cat, the cat will think the dog is coming towards me with a velocity of v minus u cos theta. Isn't that how we do in relative velocity? We subtract the velocities. We take the dog velocity and subtract it from cat. Have a look at this. How did you get the relative velocity? See, this is what we do, right? We subtract here u cos theta, u sin theta. So here also we do u cos theta and u sin theta. So u cos theta, this will cancel. This will cancel. So the cat will come to rest, and the dog velocity becomes this. So this is what the cat will think about the dog. It is coming towards me, making a curve. But every time it is coming towards you, the velocity is always v minus cos u cos theta. So the velocity which is responsible for the cat and the dog to meet is v minus u cos theta, the v relative. We use negative sign since the distance is decreasing. This velocity is decreasing the distance. Check this out. Now, these are the two steps. Huh?
0 minus L.
What is displacement? Final minus initial position. What is the final distance between them? They met, right? 0. Finally, when they're meeting each other, what is the final displacement between them? 0. What is the initial displacement? L. So displacement is final position between them by initial position between them. Displacement will be x final minus x initial, which is 0 minus L. Clear with this? Now, this is the only way to do it. I couldn't figure out a second way. So these problems, this is how you handle them. Cats and dogs chasing each other and stuff. So once you got the two equations, bring both the equations. Ut is equal to integral v cos theta dt. And this will be integral v minus u cos theta into dt is equal to L. So from here we get integral cos theta. Now see, there's no need to integrate. I don't know theta, I don't know dt. Ut by v, take this and substitute here. We get integral v dt minus u integral cos theta dt is equal to L. So this will be v into t minus u cos theta will be ut by v is equal to L. So t will be v into L by v square minus u square. That's your answer. This is the time when the cat and the dog meet. Please look at the steps. This is the little confusing part out of all. Once you have to see with respect to the cat ka frame. So when you stop the cat at any instant, it will think the dog is coming towards the cat with a speed of v minus u cos theta. And this vu sin theta is responsible for rotating the dog. That is changing the angle. So v minus u cos theta is a relative velocity. So v relative is displacement. In relative to time is displacement. That's your second equation. And then it's just a matter of solving. Now the homework question says u is equal to v. Now see, if u is equal to v, the dog will never catch the cat. Then what is the minimum distance between them? That is a homework question. Method is same. Now you guys think about that and let me know. But do check this out. This is how you do cat and dog problems. This is another model. Last time we did particles chasing each other. That was this thing. Hexagon, 6 particles chasing each other, 4 particles chasing each other, 3 particles chasing each other. This is another model in relative motion. So in relative motion, these are the tough ones what you have done. The Riverman, Rainman, all those things are actually kind of easy. Any doubts on this? Clear? Next one. Can I go ahead, Ali? Ali? Ali, are you there? Respond, Nare. Say something. Just at least nod your head when I call your name. Aryan, clear with this? Yeah. Next thing, Rainman problems. Rainman or river umbrella. So look at the concept here. When a person walks in rain, or even when you're in a vehicle, due to relative motion, he observes the rain is falling at an angle different from with respect to the ground. He observes the rain makes an angle different with respect to the ground. The concept is simple, the same thing. Example 6. Let's say we have a person going with speed u. And let's say the rain is falling with v. Example, the rain could have actually fallen with anything. So how do we solve the problems? Solve with respect to the man. So with respect to the man, this is what we do. This is going with you. The rain is falling with v. Stop the man. How do we do that? Take the man ka velocity, subtract it with everyone. The man will think, okay, I came to rest. But he will start thinking the rain is actually falling at an angle now. This is a resultant. If you take this angle to be alpha, so tan alpha will be u by v. So you need to keep the umbrella at this angle, making an alpha. And he thinks the rain is falling with a speed of v square plus u square. So he thinks the rain is falling at angle alpha with root over v square plus u square. Whereas in reality, if you see, the rain is actually falling with v vertically, but the whole perception changes. You can actually see this, when you're going in a train or a car, right next time, observe that when it rains, when your car is at rest, the rain is falling at an angle. When the moment the car starts moving, you'll observe the rain is also actually bending. Please check the concept here. So the idea is simple. In this case, always stop the observer, always stop the man. Take his velocity, give it in reverse to the rain, then man will come to rest. And because you and you will cancel, man will come to rest. That is the whole concept of relative motion. Whoever is the observer, take his velocity and acceleration and subtract it from everyone. Please check. Darshini, are you getting this concept of subtracting? Yeah. Siddharth, clear with this? Shaurya, clear, huh? That's it. The rain man concept, this is the only thing. The rain is falling, man is going, stop the man, then you'll see the rain. Compared to all this cat and dog, rain is easy. Let's see a problem. Let's say man is going with a speed of 10 meters per second. This is the velocity of man in the ground frame. The rain is falling with a speed of 60 degrees. Velocity of the rain in the ground frame is also 10 meters per second. So the question is, simple question this is, at what angle does he see the rain falling? The second question, what should be the speed if he sees the rain falling vertically? Again, what is the speed if he sees like this? The rain is falling like this at 45 degrees. He thinks rain is coming and hitting him from behind. Get the three questions. First question, speed is 10, is running horizontally. What angle does he see the rain? Second question, if he thinks the rain is falling vertically, what should be his velocity? Third question, if he thinks the rain is falling with 45 degrees from behind, then what should be his velocity? Let's do the first one. Let's go one at a time. Mm, 30, 60, 45. Yeah, why do we have so many different answers? Let's see the first part.
Like angle from the top you're asking or like from the bottom?
Yeah,
The
it could be anything. You can say.
Can we say like the angle at which he has to hold the umbrella?
Meaning it depends. You can say angle 30 with vertical, 60 with horizontal. Same thing. Depends on. You can always go from the options. Anyway, let's see. Stop the man. So how do we do that? We put 10 backward and we put 10 this way. And because of this, the man will think, okay, I'm at rest. But now this thing is coming with, that is 10 already. 10 cos 60, 10 sin 60, and on top of it, this 10 is also there. So this guy will see that is 15, and this would be 5 root 3. So this would be the resultant. And now you can take any angle you want. If I say this is alpha, then tan alpha will be 5 root 3 by 15. That is 1 by root 3. If you take horizontal, you'll get 60 degrees. So alpha is 30 degrees. So he sees the rain falling at 30 degrees with the vertical.
The tan alpha is 15 by
Yeah,
5.
alpha will be 15 by 5 root 3, no?
Yeah, I wrote reverse. 15 by 5 root 3. You're right. 60 degrees. So he sees rain falling at an angle of 60 degrees with the vertical. If you want to say with horizontal, say 30 degrees with the horizontal. Same thing. How should he catch the umbrella? So he should catch the umbrella like this. That also will be alpha. So he also should catch the umbrella at an angle of 60 degrees with the vertical or 30 degrees with the horizontal. Easy? Everyone got this? Simple, right? Stop the man, give the velocity opposite to the rain, opposite to the man cup to the rain, and then get the result and finish it off. Get the other two parts B and C. Keep going. Any doubts on the first part, please ask. Second question, see, what should be his velocity if he sees the rain falling vertically? Okay. Ah, Pratyush, that is right. Any doubts on part A, please ask. Okay, Kansh, let's see, that might be there. Anay, are you clear with the first part? Vivan, clear with the first part? Aryan? Sure with the first part. Arya? Clear. Ali, clear na first part? Sharja? Clear. Second one, keep going.
Sir, in C case, speed of train is same.
Come again.
In case C, speed of rain is same in question C.
Yeah. Rain ka velocity will never change. Only man ka we are asking. Anika, that looks right. Finish up both of them, everyone. I'll give you a minute more. Then I'll show you both. Let's see. Show you the second and the third part. This was easy. This was the standard stuff. Let's see the second part. Now, I don't know how is he going, okay? Doesn't matter. Assume any direction. Let the man go with V horizontally. The rain is falling with 10 meter per second at an angle of 60 degrees. The idea is the same. Stop the man. So let this be V backward and V backward. So the man will come to rest. And he thinks it is going backward with V plus, and this is 10 cos 60. And downward is V sine 60. You want to see the rain vertically? The horizontal component should be 0. To see the rain vertically, V plus 5 should be 0. V is equal to minus 5. Minus indicates it is not going forward, it's going backward. Are you getting it? So even if you don't know which way is actually running, you assume any direction, the science will take care of it. Clear? What about the C part? C part, the story is the same. If you stop the man, he will think it is going forward with how much is this? Minus V, minus 5. And this would be V sine 60. Sorry, this is 10 sine 60. And you want to see this angle here at 45. So tan 45 is minus V minus 5. What I did is simply reverse this vector in this direction. So the whole thing will become a minus. Or in your confused, I'll just write this thing like this. V plus 10 cos 60 by 5 root 3 is equal to 1. So we get V is equal to minus of 5 root 3 plus 5. The minus indicates man is not running forward, man is going backward. So sometimes you get confused, is he running forward or backward? Don't worry about that. You just assume any direction. The science will take care of it. This is an easy one. And like I said, Rain Man and Riverboat are actually easy compared to what we did before. Clear with this? Next one. Next one is a good one. Any doubts on this? Please ask. Next one. We have a incline like this. This is 30°. This is 60°. This is A, B, C, and D. And we have a man here who is walking on the incline with a constant speed. Next thing, man walks with a constant speed, 10 meters per second on ABC. It doesn't matter whether you're walking on the incline or flat or this thing, he is just walking with a constant speed. Right? 1 second. Yeah. So listen carefully to the data here. When this guy is going on the line AB, on AB, he sees the rain falling vertically. Now, no information is given about the rain. Meaning on A to B when he's going, he thinks rain is falling like this. He thinks, whether it is falling or not is a different story. On CD, he sees rain parallel to CD, hitting on his back. Meaning on this incline CD, when this person is going down, he thinks rain is coming and hitting like this. The question is, at what angle does he see the rain when he's walking on AB, on BC? Let's get this. Man ka speed is constant. That does not change. Rain ka information is not given at all. So using that AB and CD ka data, we need to figure out the rain ka velocity. If they ask an advanced question, will be of this sort. All those previous things, they really, you really can't ask too much on Rain Man in advance. But if they want to do something of this sort. How do we proceed with this? In this kind of scenarios, right, when you don't know what is happening, actually I'll tell you one thing. Start from CD. The problem starts from CD. From there, you can actually figure out something about the rain. I don't know rain ka angle, I don't know rain ka speed. If I know these two, my job's done actually. How do we proceed with this? Think about it. Anay, give it a try. Everyone should try this. Take this seriously, everyone. Try. Aryan, give it a try. Sure, I'll show you something. Look at CD. There's a big hint there only. When the man is walking on CD, he thinks the rain is hitting him parallel to the incline. इतना कुछ long नहीं है आकांक्ष. See, if like this, so you'll ask for 3-4 hours only next. 5 minutes it seems. Now see, look at here. Velocity of rain Now, if you just symbolic form with respect to the man, is velocity of rain with respect to the ground minus velocity of man with respect to the ground. Agreed? Isn't this the formula? Velocity of the rain as seen by the man. Stop the man velocity. Now observe something here. Velocity of rain as seen by the man. This is parallel to CD. Velocity of man is also parallel to CD. If you add two parallel vectors, what will happen to the third vector? If this is parallel to CD, this is parallel to CD,
Will
shouldn't
also
this
be
be
along
parallel to
that
CD?
line.
So
That will also be
therefore,
parallel.
if you observe, velocity of rain in the ground frame must be parallel to CD. Is that making sense, everyone? That's your information. So, abhi rain ka speed to we don't know, but I'm sure this is the velocity of the rain, which is making an angle of 60 degrees. This much we know now. The rain is actually falling at an angle of 60 degrees with the horizontal. Speed we still don't know. Rain is falling at an angle 60 degrees with horizontal. There's no need to be super max here. You can just see and say, if these two are parallel, the third vector should be parallel. Okay. Now try from here. I'll give you another 1.5 minutes. Now how to proceed from here. Now to this information, you know. Now, when you're going on AB, you think the rain is falling vertically. So what is the angle seen by the man when he's walking on BC? You can just have a look at this once. Clear with this page, everyone? Anika, got this? I hope this logic was clear. Now, can you try the answer? Try. You got a minute more. So that is CD. You start with the problem from CD. So the rain is actually falling at an angle at 60 degrees. Because if you are going along CD, the rain is falling along CD. That means that is the reason the relative velocity is also along CD. Try. Everyone should try. Show you next part. See. 30 degrees you got. Okay, let's see. So when you're going on this AB, so just now we saw the rain is actually falling at an angle So this is V rain at an angle of 60 degrees. So let this components be V cos 60 and V sin 60. And we have the man here at 30 degrees. He's going with a speed of 10 meter per second. So his components will be, this is also 30 here. This would be 10 cos 30 and 10 sin 30. Now you need to stop the man. So what do? We reverse the velocities. 10 sin 30, 10 cos 30. So you have to subtract them in the reverse direction. So this is 10 cos 30 and this is 10 sin 30. So on AB, this person thinks, okay, I came to rest and the velocities will be V cos 60. This is 10 cos 30 and this would be V sin 60 plus 10 sin 30. Now he sees vertically. Therefore, that V cos 60 should be equal to 10 cos 30. V is equal to 10 root 3 meters per second. So this is the actual speed of the rain, everyone. Check. So the rain is actually falling at 10 root 3 meters per second at an angle of 60 degrees with the horizontal. This is how we found the actual velocity of the rain. Clear? Now the actual thing. Question is still not over. So now we have this person on BC who is going with 10 meter per second. The rain is actually falling with 10 root 3 at 60 degrees. So resolve this into components. 10 root 3 cos 60, 10 root 3 sin 60, subtract 10 backward and 10 backward. Numbers are not that great. So man will come to rest. The horizontal velocity will be 10 minus 5 root 3 and 10 root 3 by 2, 5, 3, 15. If you take this angle as alpha, so tan alpha will be opposite 10 minus 5 root 3 by 15. 2 minus root 3 by 3. Check. So he thinks the rain is falling at this angle. 2 minus root 3 by 3 tan alpha with the vertical. Like I said, this is a good problem. Advanced, if they ask you, it will be of something of this sort. Please check. All clear with this? Can I go ahead?
Sir, can you please show the previous page? Thank you, sir.
Next thing. Riverboat. Or rainman, riverman, or aeroplane man. Meaning all are based on the same concept here. Now, what is the main idea here? See, when you say a river is flowing with speed u, the meaning of this is if an object is dropped into the river, right, it will move with the velocity of the river. So it will get dragged away. So if I take you and throw you into a river, you will get dragged away with the river with speed u. It will move with the velocity of the river. Next thing, if you say velocity of man with the still water, meaning if the river was not moving, it would have gone with v. Now let's see the different cases in this. Case 1, man swims along and opposite to the river.
Sir, can you show the previous slide? Okay, sir.
No?
Yes, sir.
Man swims along and opposite to the river. Listen to this, we have 4 cases. You got them, it is pretty easy there. So let's say the river is going with you here, and the man decides to swim like this. So in this case, the river ka speed will add up to him. So velocity of the man in the ground frame will be v plus u I cap. He's going with v forward, and the river is also pushing him forward. Same thing, but if he decides to go opposite to the river, in this case, velocity of the man in the ground frame would be minus of v minus u I cap. If u is greater than v, it will be in the reverse direction. You could have written like this also, u minus v I cap. Depends on who is greater. Is this idea clear? Straightforward. If you go with the river, the speed will add up. If you go opposite to the river, the speed will subtract. Easy? Have a look at this. Let's see a question on this. Case 1, people. Any doubts on case 1? Please ask. It's a straightforward one. So we have an escalator here. And a person stands on a moving escalator. It takes time t1. Here, escalator is just like a river flow. And for some reason, let's say you went to the mall and escalator is at rest. Escalator is not working. So you decided to start walking. Man walks up and takes time t2. Third case, you're going to a movie, you're late to the movie theater. So escalator is going up and you also decided to walk on the escalator. Find the time taken to go up. Is the question clear? Escalator is going up. You went there and you stood on it. It took time t1 to reach the top. Second case, escalator was not working. You started walking. You took time t2. Suppose if you decide to walk on the moving escalator, now what happens? When walking on a moving escalator, I'm sure you must have done all these three cases. Get this. So here escalator is like river, man walking is like swimming. If you say it's really not that different. Get this, you got a minute. Okay, that looks right. Let's see. Try others. Are those answers? Try. We have one answer so far. You need to type to the co-host in case maybe you're typing it wrong to some other thing.
So what all variables are we supposed to use here?
T1, T2, what else is there? There is nothing there only, na? Arya, there is nothing else there. Ekansh, that looks right. Let's see. Anshul, yeah. 30 seconds more. See, now we don't know what is the speed of this escalator. Let the speed of the escalator be v1. So time t1 and let this length be L. So the time t1 here will be L by v1. Here length L2 and let the speed of the man be V2. So time T2 will be L by V2. Now in this scenario, the man will be going with speed of V1 plus V2, no? Isn't it? It will add up. So time T3 will be L by V1 plus V2. So V1 will be L by T1. V2 would be L by T2 and just have add up here. L3 would be L by T1 plus L by T2. This would be T1, T2 by T1 plus T2. Check. Easy. Clear this, everyone. I think, yeah, Arya, you got it right. Ekansh, Anshul, Anika. What happened, Lakshika, today? No answers. Tired. Next one. Others all got this? Vivan, Pratyush, sure with this? Anay, Siddharth, no answers today. Sharja, clear. Ali, clear now. Next one. Let's do this one. This is an Erudoka first question. Let's get this. How do we do this? First, try to understand what is happening there. A motorboat going downstream overcomes a raft. The meaning of the statement is someone just throwed a wooden plank into the water. You get the PDF, right? Use your time to solve the questions. Use your time to solve the questions. Let's not waste time on. Get this. Get this. Try it. It's a good question. I'm just explaining the question, anyways. I hope you're getting the question. So you just throw a wooden ka raft. So if you throw a wooden ka plank, what will happen? It will drift with the speed of the wave. That's the meaning of that. A motorboat meaning you have a boat which is going in the lake now. Read the question. Try. You got 2 to 3 minutes. 2 minutes. It's fine. If you draw the diagram, you'll see the answer. Anyone still confused with the question? Please ask. I'll explain again. Question is clear. Go ahead for 2 minutes. Anyone not clear with the question? Please ask. Try to draw the diagram. That itself will explain the whole thing. Should I show the diagram? See the diagram. Like I said, if you can draw the diagram, you'll understand. So this is the river. Let the river go with the speed u. Overcame a raft at point A. So there is no angle here. Okay, fine. Again, no? Okay. This is point A here, and this is the raft. And this person here, the motorboat, after 60 minutes, it turned back and after some time passed the raft at a distance of 6 kilometers. So this thing went down, took a turn, and came back here. In this process, the raft has come from here to here. Is this making sense? That is the diagram here. It went, came back again. So this was t0. After 1 minute, it took a turn. So this is t is equal to 1 hour. Then it took a turn and it met the raft somewhere here. And he's saying this is 6 kilometers from point A. Is the diagram clear now? Now, during this entire process, the raft is going with a speed u, but the boat here is going with v plus u. And while coming back, this part, I'll put it in green, it is going with v minus u. I hope you're getting the scenario there. When you took a turn and started going back, your speed has become v minus u. Now, can you try? I'll give you another minute from here. Anshul, now is it better? Try everyone. I hope you got the diagram. See, interpreting the data and drawing a diagram is the most important thing. Try. Just give it a try. This at once. Get some water and come. Let's see. Anyone got the answer? 3. Yeah, is it 3? Might be, yeah, 3. Yeah, one answer, everyone. Others?
Just 1 minute, I'm getting 1 minute.
Yeah. See. So from here you can clearly see, let this thing read 1 hour, right? And let this time be t. From here to here. That means the raft has traveled for total time is 1 plus t. Let t be the time and it turns back. So that means the raft has traveled for a total distance u into 1 plus t is 6 kilometers. And this guy has traveled for v plus u into 1 minus v minus u into time t should be 6 kilometers. Agreed? This distance minus this distance should be again 6, right? You're done. This is equation 1 and this is equation 2. Substitute that 6 here. We end up with v plus u minus vt plus ut is equal to u plus ut cancels, u cancels. T is equal to 1 hour. Means it took him 1 hour to go back. Put this in the equation 1. You get u is equal to 3 kilometers per hour. Check. This is how you do in the ground frame, but there's a much faster way to do this. Do look at the steps. I took this total red cut distance minus green cut distance. I'll do one thing. I'll shade this in red in color. So this is v plus u into 1. That's a distance while going down. This is v minus u into t. This is the distance while coming back. The difference should be 6. Is that making sense? All clear with this? But there's a much faster way this, Stop the river. Study with respect to the river. Now you tell me, if you stop the river, what will you think about the raft? Raft is at rest, no? If you stop the river, means you're standing on the river at that point. Don't you think the raft is at rest? So with respect to the river, then boat is going with speed v. Means the boat will go down for 1 hour. While coming back, it has to come back for 1 hour. Because this v is the speed of the boat with respect to river only. So if it goes down for 1 hour, it has to come back for 1 hour. Therefore, total time is 2 hours. Total time is 2 hours. That means the raft has traveled for 2 hours. So speed of the raft into 2 hours is 6 kilometers, u is 3. This is an alternate method, which is faster. So this is a relative friend. Stop the river. Is this making sense? If you stop the river, you will think the raft is never moving. Raft is just there only. And the speed of the boat is v with respect to the river. So if you're going on the river, the person on the river will think the boat is always going with v only, front and back. Is this clear, everyone? This is a much faster way. This is fine. This will make you feel like, okay, what is happening exactly? But this will give you the answer faster. Please check. Clear? No. V is what? V is the velocity of the boat with respect to still water, isn't it? If you stand on the river, do you think the river is flowing anymore? So it is V only, na? Ekansh, it's like this thing. Let's say bus is going with some speed 10 kilometers per hour. I'm sitting in the bus. You're also in the bus with me only. So if you're walking front and back, don't I think your speed is constant? The person on the ground will think your speed is different, but the person in the bus will think you're just walking with constant speed, right? Front and back. Is this getting everyone? The riverboat problems, right, are similar to a man walking inside a bus and the bus itself is moving. Are you getting this, everyone? Great. Next thing. So that's your case one. In the question he said, no, it took 1 hour to go down. It took a turn after 1 hour. So if you're going with constant speed, if you go 1 hour down, won't you take 1 hour to come back? Right, I can. Case two. Minimum distance. Now these are all our standard cases. Let's say the width of the river is D. This is point A and this is point B. So here we have a man who is swimming, who can swim in still water with V. The river is flowing with U and V is greater than U. So minimum distance means he just wants to go to the point exactly opposite. Now you tell me, if he swims straight, will he go to B? So this is how we start the problem. Let the man swim at an angle theta. Now see what happens. So the man has two components, V cos theta and V sin theta. And the river is dragging him with speed U. So to go straight, V sin theta should be equal to U. Sin theta is equal to U by V. So if the man is swimming, man wants to go along the line AB, he has to swim with this angle. To move along line AB, the horizontal component should be 0. You know what is the meaning of this? The man is actually going like this. The man is looking like this, okay? The man is looking like this, but he's going straight. So here the man is looking at an angle theta, but he's going in a straight line. It's like, you're looking to the left and you're walking straight. Are you able to see it? Understand? You're looking somewhere else. You're swimming, in some other direction, but you're going in some other direction. Man is looking, at an angle theta, but he's going in a line AB. This is because of the river drift, but he moves along AB. There, you're seeing somewhere else, but you're going somewhere else. So your head will be pointed that way. And what about the time taken to cross the river? The velocity responsible to cross the river is V cos theta. So that will be d by V cos theta, which will be 1 minus sine square theta. That will be U square by V square. That will be d by root over V square minus U square. If you can mug up the results, it will be great. You can't remember, it is fine. You should know how to derive. So this is the minimum distance. You need to swim at this angle to go along the line AB, and this is the minimum time to go from A to B. Check. All clear with the second case. Saurja, Ali? Clear with the cases? Siddharth, Anshul, Lakshika, clear, na? Pratyush, Anay, Arya, clear. Aryan, Vivan, Anika, clear. Ekansh, got this. Can I turn the page? So, if I ask you a question like this. So, we have a river. Which is flowing with a speed of 3 kilometers per hour. So, we have a swimmer. Velocity of the man in still water is 5 kilometers per hour. So this guy decides to swim like this. A, B, C, and D, a square. This is a square of side 2 kilometers. The man swims. When you see him from outside, right? It looks like he's going along the square. The man swims along the square ABCD. Find the time taken for one revolution. Find time for one round trip. So you made a square ka path, and this guy is literally swimming along ABCD. So if you put a GPS, you will see a square on that river ka path. To find the time taken for him to make one full round trip ABCD. Try. Two point three three 9/4. If you observe clearly, there's a case 1, case 2 both combined. Hope you realized it. Show you 41/20, 9/4, 2.4, 2.33.
Four, four.
Try. I'll give you a minute more. Not a single answer is matching. 2.25. I think we have two answers which are matching. Let's see. So when we are going along the path A, B, C, D, you know how is he swimming? This man is actually swimming like this at an angle theta. So this guy was actually going like this. He's looking like this, but he's going along AB. So this man ka speed is actually V cos theta. So time taken to go from A to B will be the side of the square D by root over V square minus U square. So once you go here, B to C, the man is swimming like this. And the speed will be V plus U. So time taken to go from B to C is D by V plus U. And once you're going from C to D, remember in all this scenario, the river is flowing this way horizontally. Here, the man is swimming like this at an angle theta. Means this guy is looking like this, but he's going in a line like this. Again, this is V cos theta. So time taken to go from C to D is D by root over V square minus U square. And when he's swimming here, he's going opposite to the river flow, is actually swimming with V minus U. So time taken to go from D to A is D by V minus U. Hope everyone did the same. So the total time will be D by root over V square minus U square plus D by V plus U plus D by root over V square minus U square plus D by V minus U. I will leave the numbers to you. So here D is 2 kilometers, V is 5 kilometers per hour, and U is 3 kilometers per hour. How much will that be? V square minus U square is 4. That is half. That is 1 plus 2 by 8 plus 2 by 2. That is 1. Yeah, that is 2 plus 1.4, 2.25 hours or 9 by 4. Check. Yeah. Right, everyone. Shaurja, Siddharth, Anika, Nakshika. Yeah, most of you got it right. Easy? All got this? That's your shortest distance. Any doubts on this? Please ask. Next one. Can I turn the page? Perfect. Next one. Case 3. Shortest time. If your intention is just to cross the river, you don't care about anything else. You just want to cross the river in the shortest time. So the idea is the same. We always start like this. Let the man go at an angle V and theta. So the velocity responsible for crossing the river is V cos theta. So the time would be D by V cos theta. So for minimum time, cos theta should be maximum. So that is theta is equal to 0. Means man should swim straight. Now see how it looks. But because he's swimming straight, he won't go to the opposite point. The river is pushing him. So velocity will be V and the river is pushing him with U. The man is going at somewhat like this, point C. So see, this is how the man looks. The man is looking straight, but is going somewhere else. Are you getting? You're seeing straight, but you're going to point C. This distance here is called a drift. answer. This is BC. It's called drift, that is given by the horizontal component of the river, horizontal distance traveled, or the displacement in the direction of the river. So that would be u into time taken, and which will be u into d by v. Check. All clear with this? I hope you're getting it. Riverboat problems. Much easier than what you have done last class, relative motion. Please check. Any doubts on this? So the main idea, right, here is you're seeing somewhere and you're always going somewhere else. Anyone saw this movie? Oh, Hrithik Roshan ka Mohenjo-daro? If you've seen that movie, right? Good. If you look at the climax, now there was a big flood and the city is getting flooded. So Hrithik Roshan literally explains this question there. He's like, he goes there and all the villagers are trying to escape. He tells them, since we want to go to the opposite bank, if we go straight, we'll get a drift. So therefore, we need to go at an angle like this thing. So we will literally he explains this problem. I had a feeling like, the scriptwriter must be a J preparation student, J student. Let's see a question. All clear with this? He explains case 2 and case 1 properly. You guys can go and check it out. I found it funny when I saw that, but okay. Let's see this question. I'll send a small sheet on maybe 20 questions on this relative motion, Rain Man and Riverboat. Get this. Try. Now see, this is not case 1, case 2, case 3. Huh? This is nothing. This is a more general one.
Sir, is it multiple choice?
Yeah. Okay. Other answers? Try, everyone. Finish off easy one. So be careful here. You want to go along the line AC. He's not asking that. He's asking how should you swim so that you'll go along AC. And D is not the answer. Check your answer again, Anand. Show you? See. Let's understand the diagram. You want to go along the line AC. Okay. That means you're actually going at some angle like this. Let's call this angle some alpha. Let's call this full angle alpha. So change the color bit. You're going at V at an angle alpha. So this horizontal component will be V cos alpha. The vertical component will be V sin alpha. On top of this, the river is pushing you with 1 kilometer per hour. And your final motion is along this line here. And this angle is 45. So this is what is happening. So if you look at the Manka speed, the vertical component is V sin alpha. The horizontal component is V cos alpha plus 1. The resultant of these two should be along 45 degrees. I hope everyone is getting the meaning of it. He is not swimming along AB. So from here we can clearly see tan 45 should be V sin alpha by V cos alpha plus 1. So from here we get V will be okay, he's swimming with the speed of 5, right? Okay. So we get 5 sin alpha is equal to 5 cos alpha plus 1. Now you can clearly see here alpha is the only one which satisfies this condition. Sin alpha minus cos alpha is equal to 1 by 5. You can use little geometry, but you can clearly see alpha is 53 degrees. First option. And what about time? The only component which is responsible for crossing the river is V sin alpha. Time will be the line AB by V sin alpha. A to B is 400 meters. 0.4 B is 5. And sin 53 is 4 by 5. That is 0.1 R. 1 hour is 60 minutes, no 60 minutes. Check. Is this clear, everyone? The man is not swimming along AB. He is actually swimming along this black line, but he is going along the red line. So let man swim at an angle alpha with vertical, horizontal. All clear with this? Please check. Anay, got this thing? Pratyush, Ekanksh, Arya, clear? Last case, case 4. What if the man ka speed is less than u? So the problem is he can never reach the opposite point B. Since V is less than u, he can never reach the opposite point. This is the case for minimum drift. Since you can't reach the opposite point, what is the closest you can get? So this is how we start. The story is always the same. Let the man swim at an angle theta. So the vertical velocity will be v cos theta. The horizontal velocity will be u sine theta minus v, meaning the person will go somewhere to point C. So this is what is happening, everyone. He's looking like this, but he's going along the green line. This is your drift, the BC ka value. You want to minimize that function. So the time depends on the v cos theta. The drift depends on the horizontal velocity, which is u sine theta minus v into time. So we get u sine theta minus v into d by v cos theta. So this is the drift as a function of theta. For different values of theta, you get different drifts. So he's asking for minimum drift. We need to differentiate dy d theta maximum minimum, everyone. D drift by d theta is equal to 0. Have a look at this. Let me show it on the next page. So we got a drift as a function of theta. So for if we goes with theta, 0 degree, 10 degree, 20, 30, you get different drifts. Among all of them, there is one angle which will give you the minimum drift. So we need to find that minimum drift. Have a look at this page. I'll show you that calculations in the next page. Any doubts on this page? Clear? So the drift is u sine theta minus v d by v cos theta. Just multiply, you end up with ud by v tan theta minus d sec theta. And you're planning to differentiate this guy, d by d theta of drift. This will be ud by v. Tan ka differential is sec theta tan theta minus d. Sec ka differential is tan ka differential is secant square theta minus d sec ka differential is sec theta tan theta is 0. Once sec gets cancelled off, you end up with secant theta u by v is equal to tan theta. We got a pretty nice answer actually. Sin theta is u by v. Be careful. Case 1, sin theta is I wrote wrong. Sin theta is v by u. Yeah. One sec, we'll cancel this sin by cos. Somewhere I go with the differentiation only, I guess. Differential tan theta, tan ka differential is 6 square theta. Uh, Where did I mess up? Arey yaar, this is v sine theta minus u na. I was thinking where it messed up. V sine theta minus u minus v sine theta. This is ud by v sec theta minus d tan theta. I goofed up. Sec theta tan theta minus d sec square theta is 0. We get a pretty nice answer. Sine theta is equal to v by u. Be careful between this and case 2. If you remember, case 2 ka result was sine theta is u by v. And here v is greater than u. Obviously, sine theta should be less than 1. Here the answer is sine theta is v by u. And the minimum drift will be, substitute there, u minus v sine theta is v by u by d by v cos theta, which is root over 1 minus u square by u square minus v square by u v d by root over v square minus u square by u. When u cancels off, we get d by v root over u square minus v square. That's your minimum drift. Please check. That's case 4. So these are the 4 cases that we have, and then we have all general problems. Do have a look at this, what we did. So next class when we meet, we're going to do more problems on this. So next class we'll wrap up with riverboat. We'll do more variations of this, and then we'll start off with graphs introduction. So graphs is the last part in the kinematics. Okay, so with that we'll wrap up for the day. So the next week ka test is already online. You can start checking it out. The last test ka result will be posted tomorrow, right? And the next test will be online till Wednesday night. So make sure to give it. So, okay. Any doubts? Anything? Stay back and ask me, or else you're free to leave. So take care, stay safe. I'll see you guys on Monday, 8:45 as usual. Any doubts in today's class or any other doubts, you can ask me, or else you're free to leave.